Students, I welcome you all to this lecture. In this video, we are going to discuss about higher level MCQs from the chapter Continuity. Let's begin now. Look at the first question. Two functions are defined, f of x and g of x. F of x is mod x minus 3 when x less than 1, mod x minus 2 plus a when x is greater than or equal to 1. G of x is 2 minus mod x when x less than 2, signum of x minus b when x is greater than or equal to 2. Another function h of x is defined as f of x plus g of x. If this function is discontinuous at exactly one point, we need to check the possible values of a and b. So let's start the solution now. First, let's recall the definition of mod x, which is minus x when x is less than 0 plus x when x is greater than or equal to 0. Similarly, mod x minus 2 is minus of x minus 2 when x is less than 2, x minus 2 when x is greater than or equal to 2. Next, signum function. How is the signum function defined? When x is 0, f of x is 0. For all x greater than 1, f of x equal to 1. For all x less than 1, f of x equal to minus 1. So this we have already discussed in first PU class. Now, let's first redefine f of x and g of x before we add them and get h of x. So when you redefine f of x by using the mod function definition, when x is less than 0, it is minus x minus 3. When x is between 0 to 1, it is going to be x minus 3. Next, when x is between 1 to 2, it is minus of x minus 2 plus a. When x is greater than or equal to 2, it is x minus 2 plus a. Similarly, g of x can be redefined as whenever x is less than 0, 2 minus of minus x, so 2 plus x. Next, when x is between 0 to 2, it is going to be 2 minus x. Next, when x is greater than or equal to 2, signum function becomes 1, so 1 minus b. So we have redefined f of x and g of x by using the mod function and signum function. Now let's define h of x, which is f of x plus g of x. Let's add the two functions. First case, when x is less than 0. So when you add this and this, you will get minus 1. Next interval between 0 to 1. So between 0 to 1, it is x minus 3 plus 2 minus x, which is also equal to minus 1. Next interval between 1 to 2. Between 1 to 2, it is minus of x minus 2 plus a, and here it is 2 minus x. So when you add, you get plus 2, 4, minus x minus 2x plus a. 4 minus 2x plus a. When x is greater than or equal to 2, it is going to be x minus 1 plus a minus b. Now, I can combine these two and write h of x as minus 1 for all x less than 1. Between 1 to 2, it is 4 minus 2x plus a. When x is greater than or equal to 2, it is x minus 1 plus a minus b. Observe this function h of x. For all x less than 1, it is a constant function, so it is continuous. Between 1 to 2, it's a linear function and hence continuous. 2 to infinity also a linear function which is continuous. Now, we are left with 2 points, x equal to 1 and x equal to 2. Now, at x equal to 1. So, this function h will be discontinuous at x equal to 1 when h of 1 minus is not equal to h of 1 plus. What is h of 1 minus? Minus 1 is not equal to 4 minus 2, 2 plus a, which means that a is not equal to minus 3. Next, at x equal to 2. So, h will be discontinuous at x equal to 2 if h of 2 minus is not equal to h of 2 plus. What is h of 2 minus? If you put x as 2, this will become 4 minus 4, 0 plus a not equal to 2 minus 1, 1 plus a minus b, which means that b is not equal to 1. Therefore, h will be discontinuous. H will be discontinuous exactly at one point, which is what they have given in the question, if a equal to minus 3 or b equal to 1. So we observed that the function h of x is continuous in the intervals x less than 1, between 1 to 2 and x greater than 2. So at 1 and 2 we discussed. So we conclude that h will be discontinuous exactly at one point if a equal to minus 3 or b equal to 1. So the correct option is B. Hope it's clear to all of you. Let's go to the next question. Question number 2. Look at the question number 2. F of x equal to step x plus root of x minus step x for all x greater than or equal to 0, sin x for all x less than 0. You need to check the continuity of the function f of x. Okay. Now observe that for all x less than 0, f of x is sin x, which is always a continuous function. You know the graph of sin x, so it is always a continuous function. Sin x graph will be like this, so it is a continuous function. Next, for all x greater than 0, if you consider f of x, how is it defined? Step x plus root of x minus step x. How is the step graph, step function graph? It is going to be like this, as you all know. And you observe that this step function is continuous at all non-integral points. So, step x is continuous at all non-integral points. X minus step x is continuous at non-integral points. Hence, root of that and also sum of it. So, f of x equal to step x plus root of x minus step x is continuous at all non-integral points. This is from the graph and also from the algebra of continuity of functions. So, f of x equal to step x plus root of x minus step x is continuous at all non-integral points where I have taken x to be greater than 0. Now, let's discuss at all integral points. So, let me consider an arbitrary point C from the interval 0 to infinity and C be any integer. Non-integral we have already discussed. So, I am taking C to be an integer from x greater than 0. This interval 0 to infinity. Now, the left hand limit is f of C minus, which is nothing but step of C minus. Look at the function. So, where I substitute x as C minus plus root of C minus minus step of C minus. So, what is step of C minus? It is C minus 1 plus root of C minus of C minus 1. So, C minus 1 plus 1, which is nothing but C. Next, right hand limit, that is f of C plus. So, this is step of C plus root of C plus minus step of C plus. What is the value of step of C plus by definition? Is nothing but C plus root of C minus C. So, this is C plus 0, which is C. Also, f of C is C plus root of C minus step C. Step C plus root of C minus step C, which is C plus root of 0, which is C. C minus C 0, so it is C. So, what you observe here is at x equal to C, which is an integral point, you prove that if LHL equal to RHL equal to f of c. So what is the conclusion then? This implies f of x is continuous at all integral points. Because c is an arbitrary number, at c, which is taken from 0 to infinity, taking it as an integer, we are able to prove that left hand limit equal to right hand limit equal to value of the function. So this function is continuous at all integral points. Already we have checked that it is continuous at all non-integral points in the interval x greater than 0. For all x less than 0, f of x is sin x, which is a continuous function. So now we are left with only at 0. So now at x equal to 0, let us discuss about the left hand limit. So the left hand limit is, the function is defined this way, you see. For all x less than 0, it is sin x. So left hand limit at 0 is going to be sin 0, which is 0. And right hand limit f of 0 plus is step x plus root of x minus step x. This is also 0. And what about f of 0? If you put exactly x as 0, you will still get 0 plus root of 0 minus step 0, which is also equal to 0. So at 0 also the function is continuous, because left hand limit, right hand limit, value of the function all are equal. So LHL equal to RHL equal to value of the function. So all cases are discussed. At non-integral points the function is continuous. At integral points the function is continuous. When x is less than 0, f of x is defined as sin x, which is also continuous. And at 0 we have discussed separately left hand limit, right hand limit, value of the function. So we conclude that f of x is continuous everywhere, which can also be written as f of x is continuous for all x belonging to R. So the correct option is C. Hope it's clear to all of you children. Let's go to the next question. Look at the next question. The function f of x equal to m e power mod of sin x minus n cos x minus mod x by x squared when x not equal to 0, and when x equal to 0 it is p, where m and n are integers, is continuous at x equal to 0. The different options are given. As the given function f of x involves mod function, we need to discuss LHL, RHL separately. So first we will discuss about left hand limit at 0. So left hand limit at x equal to 0, which is limit x tends to 0 minus f of x. Now let me substitute limit x tends to 0 minus m e power mod of sin x minus n cos x minus mod x by x squared, which can be written as limit x tends to 0 when x is negative, mod x is minus x. So this is m e power minus sin x minus n cos x, and this is going to be plus x by x squared. Now if you substitute x as 0, denominator is 0, numerator is some number, which means that something by 0, so the limit is infinite, it cannot be determined. But at x equal to 0, the function is defined as p, and we are checking the continuity at x equal to 0. So if the function has to be continuous at x equal to 0, numerator should be 0, denominator should be 0. So for the numerator to be 0, now if the numerator is 0, what we can do is we will differentiate by using L'Hospital's rule. So this denominator becomes 2x. Numerator m is a constant. By chain rule, derivative of e power minus sin x is e power minus sin x into minus cos x. Then derivative of cos x is minus sin x. So plus n sin x plus 1. So now let's apply the limit as x tends to 0 and see. So still the denominator is 0, which means it cannot be a finite limit. So to get a finite limit, let's differentiate it once again. So limit x tends to 0, denominator becomes 2. Numerator, let me keep m minus m outside. So I'm going to differentiate e power minus sin x into cos x by chain rule. So and product rule. So e power minus sin x into derivative of cos x is minus sin x. This minus sign is kept outside, plus cos x into derivative of e power minus sin x is e power minus sin x into minus cos x, plus derivative of sin x is cos x. So n into cos x, derivative of 1 is 0. Now let's apply the limit as x tends to 0. So when x tends to 0, this term will become 0, sin 0 0, cos 0 1, e power minus sin 0 1, because it will become e power minus 0, 1 by e power 0, which is 1. So minus into minus will become plus. So you will get m as the first term, plus cos 0 is 1, so m plus n by 2. So this is the left hand limit. Now coming to the right hand limit, limit x tends to 0 plus f of x, which is limit x tends to 0 plus, if you substitute the function m e power mod sin x minus n cos x minus mod x by x squared. So when you differentiate, you will get denominator as 2x. Numerator, before that what we can do is, when x tends to 0 plus, it is m e power sin x minus n cos x. Mod x becomes plus x, so this becomes minus x. Denominator is x squared. Okay. Now let's differentiate. So when you differentiate, you get limit x tends to 0, denominator is 2x. Numerator m into derivative of e power sin x by chain rule is e power sin x into cos x minus n into derivative of cos x is minus sin x, derivative of minus x is minus 1. So this can be written as limit x tends to 0, m into e power sin x into cos x plus n sin x minus 1 by 2x. So again, if you apply the limit as x tends to 0, denominator will become 0. So the limit will not be a finite one. So let's differentiate again. So this is limit extending to 0. Denominator will become 2. Numerator m into, let me keep m outside, e power sin x into derivative of cos x is minus sin x plus cos x into derivative of e power sin x is e power sin x into cos x plus n into derivative of sin is cos, derivative of minus 1 is 0. So numerator, when you differentiate, keep m outside, e power sin x into minus sin x plus cos x into e power sin x into cos x plus n cos x by 2. So now this is going to be, as you apply the limit as extending to 0, this term will become 0, this cos x will become 1, cos x will become 1, e power sin 0 is 0, e power 0 is 1, so you get m plus cos 0 is 1, so m plus n by 2. So left hand limit is m plus n by 2, right hand limit is also m plus n by 2. Now f of 0 is given as p, right? So f of x will be continuous, f of x will be continuous at x equal to 0 if m plus n by 2 equal to p. That is the condition for continuity of the function, which means that m plus n equal to 2p. Now we are given m and n belong to the set of integers. So for this equation to be true, m plus n equal to 2p, m n taken from integer set, this is possible only when m equal to n equal to 1. So if m equal to n equal to 1, you will get p also equal to 1. Therefore, the given function will be continuous at x equal to 0 if m equal to n equal to p equal to 1. So the correct option is B. Hope it's clear, children. We have found out left hand limit separately, right hand limit separately, because the question has mod function. Okay. So the correct option is B. Hope it's clear to all of you. Let's go to the next question. Next question, if you see the value of f of pi by 2, so that the function f of x defined this way: log sin x by log of 1 plus pi squared minus 4 pi x plus 4x squared into 1 minus sin x by pi minus 2x the whole square is continuous at x equal to pi by 2. Unlike the previous question, we can directly find the limit here because there is no mod function. Now, as the function is continuous at pi by 2, limit x tends to pi by 2, f of x is f of pi by 2. We are going to find the value of f of pi by 2. Therefore, f of pi by 2 is limit x tends to pi by 2. Substitute for f of x, log sin x by log of 1 plus pi squared minus 4 pi x plus 4x squared into 1 minus sin x by pi minus 2x the whole square. I am going to do some manipulations and apply some standard limit and then get the answer for this. So the first manipulation that I am going to do is limit x tends to pi by 2. Numerator I am going to write as log of 1 minus of 1 minus sin x. Denominator I am going to write as log of 1 plus pi minus 2x the whole square. Expand this and see pi squared minus 4 pi x plus 4x squared into 1 minus sin x by pi minus 2x the whole square. The next step, limit x tends to pi by 2. I am going to multiply divide by minus of 1 minus sin x in the numerator into log of 1 minus of 1 minus sin x. Denominator I am going to multiply divide by pi minus 2x the whole square. Log of 1 plus pi minus 2x the whole square into 1 minus sin x by pi minus 2x the whole square. Okay. This is limit x tends to pi by 2 minus of 1 minus sin x into 1 minus sin x is 1 minus sin x the whole square. Okay. Next, pi minus 2x the whole square into pi minus 2x the whole square, pi minus 2x whole power 4. Next, this numerator I am going to write as log of 1 minus of 1 minus sin x whole power minus 1 by 1 minus sin x. Denominator log of 1 plus pi minus 2x the whole square whole raised to the power 1 by pi minus 2x the whole square. This is by using power rule on logarithm, which is nothing but log m power n is n log m. So n log m, I am writing it as log m power n. Both in the numerator and denominator I am writing this way. Next, this is limit extending to pi by 2. If you want, you can keep the minus sign out. 1 minus sin x the whole squared by pi minus 2x whole power 4. There is a standard limit on logarithms. Limit as x tending to 0 log of 1 plus x whole power 1 by x is 1. So this numerator is of the form log of 1 plus x whole power 1 by x. Denominator also log of 1 plus x whole power 1 by x. Now as x tends to pi by 2, sin x will be sin pi by 2 which is 1. So 1 minus 1 which is 0. So this numerator will be tending to 1. Denominator will also be tending to 1. So this is 1 by 1 by using the standard limit on logarithms. So this is minus limit x tends to pi by 2. Let me write the numerator as 1 minus cos of pi by 2 minus x the whole square. Denominator, let me take 4 common. So you will get pi by 4 minus x by 2 whole power 4. Because if you put x as pi by 2, sin pi by 2 is 1. 1 minus 1 0. Denominator also becomes 0. So there is 0 by 0 indeterminate form. So we need to simplify, which is what I am trying to do now. So keeping the minus sign, limit x tends to pi by 2. As you all know, 1 minus cos x is 2 sin squared x by 2. Pi by 4 minus x by 2. Everything raised the power 2 by 4 into pi by 4 minus x by 2 whole power 4. Now you understand why this is being done. Now your theta becomes pi by 4 minus x by 2 here. So this is minus of, first you simplify the numbers, 2 squared is 4. 4 power 4 is 256. Limit x tends to pi by 2. Sin squared the whole squared is sin power 4 pi by 4 minus x by 2 by pi by 4 minus x by 2 whole power 4. So this is minus 1 by 64. When x tends to pi by 2, x by 2 tends to pi by 4. So pi by 4 minus x by 2 will tend to 0. So applying the standard limit, limit x tends to 0, sin x by x equal to 1. This whole limit becomes 1. As x tends to 0, so I can write this as pi by 4 minus x by 2 tending to 0. So this is of the form limit x tends to 0, sin x by x, which is nothing but 1. So minus 1 by 64 into 1. So the answer is minus 1 by 64. So the value of f of pi by 2, assuming that the function is continuous at x equal to pi by 2, is nothing but minus 1 by 64. So the correct option is C. So I have used the standard limits on logarithms. Log of 1 plus x whole power 1 by x as x tends to 0 is 1. And the standard trigonometric limit, limit x tends to 0, sin x by x equal to 1. And also power rule of logarithm, log m power n is n log m. Using this, I have simplified the function. I am able to get f of pi by 2 as minus 1 by 64. Hope it's clear to all of you. Let's go to the next question. F of x is defined in the interval 1 to 4, closed at 1, open at 4 as f of x equal to log of step x, x is between 1 to 3, mod log x to the base e, x is between 3 to 4. So now let's redefine the function f of x. So as there is a step function, we need to break it into intervals. So in the first interval, when x is between 1 to 2, log 1 to the base e. Step x becomes 1. So f of x is log 1 to the base e. Next. In the next interval between 2 to 3, step x is nothing but 2. So this becomes log 2 to the base e. Next. 3 to 4, it is log x to the base e. Because x is positive, So it is log x only. So log x to the base e. Now let's discuss the continuity at 2 and 3. Suppose at x equal to 2, if I consider left hand limit. What is the left hand limit? It is nothing but log 1, which is nothing but 0. Right hand limit is log 2 to the base e. So you understand that left hand limit is not equal to right hand limit. Therefore, f of x is not continuous at x equal to 2. Okay, this is the first case. Next, let me take 3. At x equal to 3, left hand limit is log 2 to the base e. Right hand limit is, if you put x as 3, you will get log 3 to the base e. Here also left hand limit is not equal to right hand limit. Therefore, f of x is not continuous at x equal to 3. Now, looking at the first option, it is broken at 3 points, which is not correct. It is broken at 2 points, 2 and 3. Next. So, f of x is discontinuous at 2 points, which means f of x is not differentiable at these 2 points. F of x is not differentiable at these 2 points, x equal to 2 and x equal to 3. So, which means that the curve f of x is broken at 2 points. So, when it is not differentiable at these 2 points, which means that the function does not have definite tangent. The function does not have definite tangent at these 2 points. So what we have done here is we have checked that the function is not continuous at these 2 points 2 and 3. So when it is not continuous, it is not differentiable at these 2 points. So the curve is broken at 2 points. Thus the function will not have definite tangents at these 2 points. So the correct option is C. The function f of x does not have definite tangent at these 2 points at x equal to 2 and x equal to 3. So after defining f of x, we check the continuity at x equal to 2 and 3, and then we have concluded that the function does not have definite tangent at these 2 points. Hope it's clear to all of you.